I'm Neeraj Kumar from CSC B section. Today we're going to discuss about nested lists in Python. A list in Python is an ordered group of items or elements. It is a very general structure, and list elements don't have to be of the same type. You can put numbers, letters, strings, and nested lists all on the same list. List can be combined in several ways. The easiest is to just add. Another way to combine list is with extend. If you need to combine list inside of a lambda extend is the way to go. This can hold any objects. Lists are objects, therefore this can hold other lists. For example, b is equal to 3 comma 1, c is equal to 1 comma 4 comma 1, a is equal to 2 comma 1, x is equal to a comma 1 comma a comma g comma 4. So it can be written as 1 comma 1 and 1 comma 4, 3 comma 1 comma 5. The other way to append a list is to use append. For example, p is equal to 1 comma 2, so p dot append comma 3 comma 4 give rise to p is equal to 1 comma 2 in brackets 3 comma 4 or print p is equal to 1 comma 2 to close of brackets 3 comma 4. However, 3 comma 4 is an element of the list and not part of the list. Append always adds one element only to the end of the list. So, if the intention was to concatenate two lists, always use extend. Two-dimensional list. There can be more than one additional dimension to list in Python. Keeping in mind that a list can hold other lists, that basic principle can be applied over and over. Multi-dimensional lists are lists. Multi-dimensional lists are the lists within lists. Usually, a dictionary will be the better choice rather than a multi-dimensional list in Python. Python provides many ways to create two-dimensional lists. However, one must know the differences between these ways because you can create complications in code that can be very difficult to trace out. Let's start by looking at common ways of creating one-dimensional list of size n initialized with zeros. In two-dimensional lists, the position of a data element is referred by two indices instead of one. So it represents a table with rows as columns of data. Accessing a multi-dimensional list has n number of approaches. First one is accessing with the help of loop. Second, accessing using square brackets. Third, adds an element at the end of the list. And extend adds the element of a list to the end of the current list. Reverse the order of the list. Making a two-dimensional list in Python. You initialize the list by list is equal to square brackets. So for each row in 2D list, initialize the row by using list.append like you did list.new initial dot n. Then get your data by using input and append it to list.i. How multi-dimensional lists are stored in Python programming language. In Python, multi-dimensional list can be implemented by fitting in a list function inside another list function, which is basically a nesting operation for the list function. Here, a list can have a number of values of any data type that are segregated by a delimiter like comma. The list can be written with comma separated values. The list can have data such as integer, float, string, etc. and can be modified as well after creation. The indexing list is pretty straightforward, with the index starting from 0 and stretches until the whole length of list 1. When a list has other lists is an element, it forms a multi-dimensional list or array. Ranged list. Ranged list is a list containing lists with different shapes as its element. This is the answer of your first question. A regular 2D list is a list having list as its element and each element has a number of elements. Regular list is a list containing lists with different shapes as its element. And this is the answer of both right and left. Regular 2D list is a list having list as its element and each element has a separate number of elements. A ranged list is a list containing lists with different shapes as its elements. Producing rows of ranged lists when visualized as output. In contrast, two-dimensional lists are always rectangular, so ranged lists should not be confused with multi-dimensional lists, but the former is often used to emulate the lists of lists in languages such as Java, PHP, Python, Ruby, Swift, and Atlas are implemented as Leafy vectors. Slicing a multi-dimensional list. Consider a vector in three-dimensional space represented as a list. Example B is equal to 8, Python. This is a one-dimensional list since there is only one index. That means that every element can be accessed with one index, that is V of I. Is sufficient to access all elements. I is the index. Even a vector 11 is 11-dimensional space is a one-dimensional. Obviously, this terminology is confusing since the dimension can refer either to space or the array. Therefore, one uses the term axis when referring to dimensions of a list. The number of axes is called. For example, we can say that vector in three-dimensional space is represented by list with one axis and list with rank 1. Having a precise terminology, we can move on to a list with rank 2. For example, a 3, 3 matrix, which describes the rotation of a vector in three-dimensional space, can be represented as a list of rank 2. In mathematical notation, we would prefer to the matrix elements as aij. In plain Python, we can represent the matrix as a list of lists. Using single-axis slicing, it is impossible to arrive at the desired result with a single small expression. Therefore, Python supports a syntax for multi-axis slicing. That is, we can write an expression like a 1 is to 3, 1 is to 3 without getting an error message. However, Python does not come with multi-axis array. It only supports with syntax. To understand better in which way Python supports multi-axis slicing syntax, the following tiny class exposes the arguments passed to method. Since Python does not come with multi-axis array, slice and ellipsis objects are almost never used explicitly in Python programs. Nevertheless, in the following example, a list and a slice object are passed to a generator which iterates over the slicing. Slices and multi-dimensional list keyword. Python slice function. The slice function returns the slice object. The slice object is used to specify how to slice a sequence. You can specify where to start the slicing and where to end. You can also specify the step which allows you to, example, slice only every other item. Slicing in Python is a feature that enables accessing parts of sequences like strings, tuples, and lists. You can also use them to modify or delete the items of mutable sequences such as lists. Slices can also be applied on third-party objects like NumPy lists, as well as Panda series and data flow. Slicing enables writing clean, concise, and readable code. This article shows how to access, modify, and delete items with indices and slices, as well as how to use the built-in class slice. Indexing. You can access a single item of a Python sequence such as string, tuple, or with corresponding integer indices. Indices in Python are zero-based. This means the index 0 corresponds to the first item of the sequence, 1 to the second item, and so on. Let's create one string, one tuple, and one list to illustrate how to use indices. Python provides the possibility to use negative integer indices as well. This appears to be very useful in practice, especially when you want to access the last item of the sequence. The index 1 corresponds to the last item, minus to the second last, and so on. Slicing in Python is similar to indexing but returns a sequence of items instead of single item. The indices used for slicing is 0 by 2 variants for the same slicing sequence start to stop. Sequence start stop step. This article explains both. When you use the syntax sequence start to get the new sequence, it will start with the item that has the index start and end before the item with the index stop. In other words, the statement sequence start stop returns the item sequence start sequence stop and all the items between them. The training sequence can contain only one item when start plus one double equals to stop, or it can be an empty sequence when start double equals to stop. When you omit start, the value 0 is taken. That is, the resulting sequence start at the beginning of the original. Data wrangling transpose code returns copy of table with rows and columns wrapped precondition table is non-driver to-do list. Data wrangling is a process of gathering, collecting, and transforming raw data into another format for better understanding, decision making, accessing, and analysis in less time. Data wrangling is also known as data movement. Importance of data wrangling. Data wrangling is a very important step. The below example explains its importance. Selling website want to show top selling books of different domains according to user preference. For example, a new user searches for motivational books, then they want to show those motivational books which sell the most or have a high rating. But on their websites, there are plenty of raw data from different users. Here, the concept of data mining or data wrangling is used. As we know, data is not wrangled by system. This process is done by data scientists. So the data scientist will wrangle data in such a way that they will sort that motivational books that are sold more or having high ratings are used by this book with this package, etc. On the basis of that, the new user never will make choice. This will explain the importance of data wrangling. Data wrangling is a crucial topic for data science and data analysis. Pandas framework of Python is used for data wrangling. Pandas is an open source library specifically developed for data analysis and data science. The process like data sorting of filtration, data grouping, etc. The data wrangling in Python deals with the below functionalities: data exploration, dealing with missing values, reshaping data, filtering data, and other. Some knowledge regarding nested lists in Python. Thank you.